My friends, welcome. Just to kind of start off, before I'll get to the numbers on the left here. For example, we got the square root of 9. We know the square root of 9 is 3, right? Because 3 times 3 is 9. Well, it turns out, okay, that before we had these square roots, we had fractional exponents, meaning we had 9 raised to the 1/2. And believe it or not, the 2 on the bottom said what two numbers multiply together to give you 9, right? Essentially, these are the exact same thing. They mean the square root. Take the square root of 9. It's just back in the day, we didn't have the square root symbol, so we used a fractional exponent. Well, that would be 3 times 3, right? So this would also be 3. So if you look over here, 16 raised to the 1/2. Well, my friends, that's saying what two numbers multiply that are the same to give you 16. Well, that's the square root of 16, which is just 4, right? So you could see it means all the same things. For example, let's say we had this 16 raised to the 3/2. Okay, well, this would say, right, what two this bottom number on the fraction of your exponent would say what two numbers multiply that to give you 16 that are the same. Well, that's 4, so we'd get 4, but we still have raised to the 3rd, and now we can complete. Well, what's 4 to the 3rd? Well, 4 times 4 times 4 is 64. All right, that's just trying to make sense of fractional exponents. So let's look at this. Okay, the cube root of 8. What three numbers multiply? Okay, what three numbers multiply? So 1, 2, 3 to give you 8. Well, it happens to be 2. 2 times 2 is 4. 4 times 2 is 8. So this would equal 2. Okay, it's the cube root of 8. And same thing here. Now notice that it's a 3. What three numbers multiplied are the same to give you 8, which is 2? And this is the same thing here. Well, 16 raised to the 1/3. Well, what three numbers multiply to give you 64? And that would be 4. And we're left with the 1. Well, that's 4 to the 1, so that's still just 4, right? And that's why over here you'll notice I kind of ignored the 1 over here. What three numbers multiply to give you 125 that are the same, right? Well, that's the cube root of 125, my friends. That's just 5. And we still have this to the 1 power. Well, that's still just 5, right? So let's go over here. What is this problem saying here over to the right? 16 raised to the 1/4. Well, that's just telling us what 4 numbers multiply to give you 16. And if you do it, that happens to be 2. So 16 raised to the 1/4 is 2, okay? Over here, let's rewrite this as a fractional exponent. Okay, so this is the fifth root of x. Well, we can rewrite that as x. Well, there's like an invisible 1 here, so 1/5, right? The number on the denominator of your fraction will signify to you what number multiplied by itself 5 times gives you x. All right, so let's go over here. Rewrite this problem as a fractional exponent, right? And this is this is like what number multiplied by itself 5 times to give you 32. We can rewrite this as 32. There's like an invisible 1 here, so 1/5. And if you do this, well, what number multiplied by itself 5 times? 1, 2, 3, 4. It's a multiplication symbol, 5. It gives me 32. Well, if you do this out, it's actually 2, and you can try this out, and you get 2 here. So let's rewrite the following problems into fractional exponents, okay? All right, so this problem over here, okay, when it's a square root, well, think about square root, you think of 2. So this would be, there's an invisible 1 here, so x to the 1/2, okay? Because this has a 9, well, this would be x to the 1/9. Okay, there's an invisible 1 there. Here, there's an invisible 1 on the y. Well, what do you think it would be? Y to the 1/22. Okay, so you can kind of see this is just an introduction of how to work with these, okay? Let's just try this. 8 raised to the negative 1/3. Well, remember, negative means that you're going to put this on the denominator. You're putting 8 on the denominator. Well, if we have something like this, 2 times 8 to the negative 1/3, right? Well, we're taking the 8 and putting it on the denominator, so we get 2/8 to the 1/3. Notice that there's no number in front of the 8, so we have to put a placeholder, which would be 1. So 1/8 to the 1/3. And now we can rewrite this as 1 over the cubic root of 8, just showing you how we can rewrite this out. Well, now we can ask ourselves, well, what three numbers multiply to give you 8? So that's 2, so this is all going to equal 1/2. Okay, that's just showing you how to work with these number here. So over here, how can we rewrite this? There's no number in front of 32, so we put a placeholder. The negative means put it on the denominator. You're dividing it. So 1 over 32 raised to the 1/5. And this is telling us, well, what number multiplies itself 5 times gives you 32? Well, that's 2, so you get 1/2. Again, you could rewrite this as 1 over 5, and then put the little 5 on the outside here to represent that it's the 5th root. Okay, hopefully you're getting the hang of this, my friends. This right here is just 1 over 27 raised to the 1/3. We always want to get a positive exponent, and we can rewrite this as 1 over the cubic root of 27, or just by looking at this, we understand that 3 means what 3 numbers multiply to give you 27, and that would be 3. 3 times 3 is 9, times 3 is 20, so you get 1/3. Okay, I'll let you finish this one off as an exercise if you want to. Okay, you can finish these ones off. Let's just go ahead and dive into maybe these ones over here. Notice how we have more than just, now it's not just a 1 on the top of the exponent. So we know it's a negative. We're putting the 27, we're dividing. There's no number in front of the 27, so we put a placeholder of 1 over 27 raised to the 2/3. Okay, we do the bottom part first. What 3 numbers multiply by themselves? That's what this 3 right here means to give you 27. Well, that's 3, so you're going to be left with 1 over 3 squared, because a 2 is still there, and now we get 1 over 9. Okay, pretty nifty stuff. Let's go ahead and try this one out over here. We get 1 over 125 raised to the 2/3. Okay, again, the denominator on your exponent tells you what 3 numbers multiply to give you 125, right, that are the same. Happens to be 5. We kind of did this problem together, so we get 5. Well, we haven't done anything with the 2, so we get 5 squared, and now we get 1 over 25. Okay, and that's pretty much how we can work with these. So let's go ahead and try these last ones here, just rewriting this into fractional exponents, and then we'll call it good. I'll change the color because I'm sure you want to see, you know what, why not? Let's use pink. So we got this right here. Well, if you want to rewrite this, well, there's a 2, there's no invisible 1 now, so now you can just write x. Now let's change the color to be a little bit more pronounced. I don't know, what do you want? I know you wanted some nice blue, so we're gonna get x raised to the 2/5. Right, the 5 tells you it's going to go on the bottom. One number multiplied by itself 5 times by itself to give you x. Okay, here, there's no invisible 1, it's a 3. So this is x raised to the 3 over 6. Well, 3 divided by 6 is 1/2. So now we can simplify that to be x to the 1/2. Okay, here, this is x 2 divided by, well, this is square root. There's no number here, so that's a 2, right? Square means 2. Oh, that just simplifies to give you x. Pretty nice. Last but not least, let's try this one out. We get x to the negative 4 over 3. Okay. Well, negative exponents, we need to put a placeholder of 1 because there's no number in front of the x, and we get x to the 4 over 3. And if you wanted to, you could rewrite this as the cubic root of x to the 4th. This is just going over problems like this, and I hope this made sense to you.